Okay, see this one. Go through this parrot. And find anything you
Okay.
can ask.
Yes, sir. Yes, sir.
That any confusion?
No. Yes.
Computational thinking. Okay. Here you will learn three terms: abstraction, decomposition, pattern recognition. Just go through.
Okay. Yes, sir. I'm done.
So what is meant by abstraction? Do you know?
Yes.
Basically, abstraction means you only concern with the upper detail, which is required, while ignoring what is not relevant for the provision of solution. You won't go in detail. Okay. And decomposition means the
Yeah.
process of breaking a complex problem into smaller parts. That is called decomposition. And pattern recognition means the identification of part of a problem that are similar and could use same solution. Okay. Now see, using abstraction. Abstraction means hiding detail. Hiding detail. And only concerned with the essential information. So rest of the information does not require. Like driving a car. You are concerned with the driving a car. Not you are not concerned how engine is working. Got the point? So
Yeah.
uh, driving, your concern is driving a car. Your concern is not that how engine is working, how car engine is working. Okay. Hiding detail is called abstraction.
Yeah.
You go through this one.
Okay. Yes, sir, I'm done.
You got it? Abstraction.
Yeah.
Can you explain?
Any, sure. So abstraction is like something like you hide, which solves the problem for you. And in computer, it is but it show the computer scientists they use it to make like models and solutions to, like
Okay.
problems.
Like they
So
have given map.
uh,
They have given maps, calendar, and timetable. Example for abstraction. How map is mapping?
yeah,
We are not concerned. We are only concerned how map is directing us. Map use
yeah,
abstraction to show what is required for a specific purpose. For example, a road map only show the necessary detail required to drive from one place to another. So we are not concerned how map is working.
yeah.
Now here you can see. Have you read this one?
Okay.
Read this one.
Yes.
That
Yeah.
now see this one.
Okay. Yes, yes,
Yeah, what happened? Is this clear?
yes.
Yeah,
This is a process of abstraction, yeah.
yeah, this is the process of abstraction. It is telling us basically when you make a program, okay, so most of the detail you hide from the user. You only show necessary detail. So have you gone through this one?
Yeah.
Okay, now see this one from here to here.
Oh,
Okay, done.
yes.
Now see using decomposition. So decomposition means breaking down the large problem into small problem. Like here you can see a program. It has converted two module, module 1 and module 2. Module 1 further divided into module 1.1 and module 1.2. All software is made according to this approach. Module 2 further divided 2.1, 2.2, and 2.2 further divided 2.2.1 and module 2.2, 2.2. Okay, this is basically uh, decomposition. Why would we do decomposition? Because we divide problem or break down problem till the problem become atomic. Because atomic could not be broken. Is this clear? So that problem can be
Yeah.
addressed easily. So you can make a code, small piece of code. Got that?
Yeah.
Just go through this one.
Sir, can you teach the pattern? Can you tell the pattern recognition?
Okay. It says pattern recognition is used to identify those parts that are similar and could use the same solution. Similarity, it identifies similarity. This lead to the development of reusable program code in the form of subroutine. We will do subroutine, okay? Subroutine means piece of code which works repeatedly. Like, have you used bold command in MS Word? in MS
Which
Word.
command?
No,
Yeah,
bold,
yeah,
bold,
bold, yeah.
bold.
Yeah, yeah,
Now it is available in MS Word. Okay, MS Word. This
yeah.
command also Word available in Excel. Okay, Excel, and I mean spreadsheet. This command also available in PowerPoint. So this code is written once, but you can use different places. You have established once, but you can use in different places. Program code in the form of subroutine, procedure and function. Basically, subroutine has two things: procedure and function. Procedure and function are used to build a piece of code which can be used repeatedly whenever required, like italic or underline. You will find these command or instruction. Italic is a procedure, underline is a procedure which works repeatedly. You can use different places, different software. So it says this lead to the development of reusable programs. So reusable means you can use italic, bold, underline again and again because you have written a code, okay, which is error free in the form of subroutine, procedure, and function. So when writing a computer program, each final part is defined as a separate program module that can be written and tested as a separate procedure or function. Okay, like here you can see module. So
Okay.
when we we start to break our program, we make a different module. So this is the one module and the second module. When you combine these two modules, it becomes the whole programs. Okay. But module one further divided into module 1.1, 1.2. So this is piece of code. These are piece of codes made separately, okay, but work together. Made separately, work together. If there is if there is any error found, we can identify, we can address, we can debug error directly. We don't need to edit the whole programs. Okay, just go to the required module where error is occurring. We can remove that error or maintain that module. Okay.
Okay.
Okay. One thing. Wait a second. Now see here, stage 3 involve abstraction and decomposition of requirement. Abstraction focuses on selecting relevant information and ignoring irrelevant data. Decomposition means breaking down a complex problem into smaller, manageable tasks, like module 1, module 1.1, module 1.2. Module 2 divided into module 2, further 2.2 and 2.3, and 2.2 further divided 2.2.21. These are key elements of computational thinking, helping to solve complex problems by simplifying them into smaller problems. So that large problem or complex problem can be broken down until it becomes atomic. Okay, as small as you make your problem. Then you solve that. Then you write its code. Now see one example. Problem. A person wishes to make a cup of tea. A person wishes to make a cup of tea. Information obtained like tea bags, milk, sugar, white mug, water, kettle,
Yeah.
teapot. Okay. The abstracted information is that we can ignore the color of the mug as this is not relevant to this particular problem.
Yeah.
Okay, got the problem? Now see decomposition. A person wishes to make a cup of tea. How to decompose? This complex problem can be broken down into four smaller problems: water, combine, personalize, and serve. Decompose the problem. Water. Fill the kettle with water and heat it until it reaches boiling point. Combine. Add the water to a tea bag in either a teapot or mug and leave for a set time. Personalize. Remove tea bag from water. Pour tea into a mug and add the sugar and milk to taste. Serve. Stir the tea and drink it from the mug. So now, how you break? Now you can see how to break up the problem. Okay, into smaller parts. 1 second. Okay, you understand this problem? How to decompose? Yes, Umar.
Yes. Yes.
Now see here, computer system, subsystem, and decomposition. Computer system consists of software, data, hardware, communication, and people. Okay. System can be divided into subsystem and further into smaller subsystem until each perform a single action. Like I tell you, bold perform only bold activity. Italic perform only italic activity. Underline perform only underline.
Yeah.
Okay. We are using MS Word. So there are a lot of command. Each command perform one task at a time and reusable. This is called procedure and function. Now decomposition means simplify a representation and understanding of system, forming the basis of top-down design. For solving problem with computer system, decomposition involve breaking down into input, process, output, and storage. So our computer basically consists of these four parts. Okay. It's a computer, but it has been divided into these four parts. Design and construction method include structure diagram, flowchart, pseudocode. Okay, we do that. Here you can see structure diagram. This is the main system. It is divided into three subsystems: subsystem 1, subsystem 2, subsystem 3. And subsystem 1 further divided into subsystem 1.1, subsystem 1.2. This is called decomposition. Got the point?
Yeah.
Okay, here you can see flow charts. Do you remember flow chart? We have done that. So you can make you can draw flow chart regarding your algorithm. It becomes easier to understand. For start and stop, we use oval shape. For process assigning a value, we use rectangle. For input output, we use parallelogram. For decision making, we use diamond box, flow line for arrow. Got that?
Yeah.
Here you can see pseudocode is a simple method of showing an algorithm. Already we have done. It describes what the algorithm does by using English keywords that are very similar to those used in a high-level programming language and meaningful identifier name. So mathematical operator are given. These are all mathematical operators we perform in algorithm, used in algorithm. Got the idea?
Yeah. Uh, yeah.
Here you can see pseudocode statement. Assignment. A value is assigned to an item or variable using the arrow. Now we use arrow. 10 is the value which is assigned in a cost variable. So everywhere we'll use cost. And a cost contain 10. Selling price is equal to price plus tax. Whatever going on right side will be stored on left side variable. This is called assignment. You got it?
Yeah.
Now conditional, we have done conditional based program. Do you remember? A conditional, a condition that can be true or false if then and if, or if then else and if.
Mm.
For an if
Yeah.
condition, the then path is followed if the condition is true. And the else path, if it is false, and else may not be required. The end of the statement is followed by and if. Here you can see the example: if age less than 80, then output child, else output adult. Okay, you understand?
Yeah.
Do you remember we have done already these kind of program? In next slide, we will do more, okay?
Yes, ma'am.
Now, conditional two, a choice between several different values, case of, otherwise, and at case. Case of is the replacement of if then else. For a case statement, the value of the variable decide the path taken. Several variables are used specified. Otherwise, path is taken for all other values. Otherwise, used in the replacement of else. The statement is added by AND case. Case is a keyword. Of is a keyword. Grade is a variable. Okay. So 1 second. Okay, you understand? And case of
Yes.
otherwise used in the replacement of else. We use else in if then else. Iteration regarding loops. This is the syntax of for to next. We have done already. A variable is set up with the start value and end value. This variable is incremented in step until the end value is reached and the iteration finishes. Okay. Here is the example. For counter equal 1 to 10, output static. Next counter. Iteration to repeat until. Do you remember repeat until? Yes or no?
Uh, what do
Repeat until loop. Do you remember? We have done that.
repeat until yeah, I do it.
In this when condition false, it it execute. Otherwise, it when it become true, it exit. Repeat until is used when the number of repetition or iteration is not known, and the actions are repeated until given condition become true. The action in this loop are always completed at least once. Here you can see counter initial value 0, repeat, and output static. Counter equal to counter plus 1 until counter greater than 10. So this is the condition. So once statement will execute before checking the condition. We also call post condition loop. We also call it post condition loop. Got the point?
Yeah,
Now while do and while is used when the number of repetition or iteration is not known, and the action are only repeated while a given condition is true. If the while condition is untrue, then the action in this loop are never performed. So counter equal to 0, while counter less than 10 is the condition. If condition is true, it will execute output static condition, and this is the increment. We remember we have done all these loops. We also start from next class. Okay,
yeah,
so it will be recalled for you. This is the input. How to take input? Input the variable name. Input and variable name. Input used for data entry. Input, and this is another variable student marks. Output. Output or print used to display information. Print command is output command. Your name will be displayed with the using this variable. Output name 1, Ali, name 3. Got that? Name 1 will
yeah,
have another value, Ali. This is nested loop. Do you remember nested loop?
yeah, I do.
This is the example of nested loop. Condition within the condition. If age less than 18, then output child. Else, if age greater than 65, then output senior. Else, output adult. Here you can see. Got that?
Yeah,
Nesting 2. This is the nested loop. You have not done nested loop, I think so. But I will discuss in next class. For number 1 to 10, this is the outer loop. It will output number. For counter 1 to number. Okay. It will run 1 to 10 times. Output static. Here it will number. It will output number and next counter and next number. This is incrementation of outer loop. Nested loop means loop within the loop. Nested loop means loop within the loop. Okay. These are comparison operator you will use in your algorithm. Go to the So in chapter 9, how much you have done? Have you done this one?
No, we just started.
Okay, just start. Now see this one, writing algorithm that provides solution to problem. So you can write structured English, flowchart, pseudocode. So these are three methods to solve the problem. Just go through. Are you ready?
Yes, sir. Yes, sir, I'm done. By the way, sir, is Python harder or pseudo?
Python can? What is Python?
Is Python harder or pseudocode?
Python. Basically, pseudocode build your logic, how to solve the problem on piece of paper. And in Python, you can check your logic using program code. Okay. So you can add it many times
Okay,
until you reach your final solution. But in pseudocode, you don't know the exact answer. Okay. It is only estimated answer. Okay.
okay.
See here, structured English. So all the number of values, ask for the number of values, loop that number of time, enter a value in loop, add the value to the total in loop, calculate and output average. If you remember, we have done in pseudocode form. Now they have given example. Below you will see the algorithm from the but you should already know section page. It says page 217 written using each of these three methods. Here is great. Okay. Like Java, Python. This is program basically, it is asking input the number, loop the number of time. Means if you we can see from pseudocode also this problem. Here you can see total initial value 0. Print, enter the number of value to average. I input a number like 8. For counter 1 to number. So loop will run 1 to 8. 1 to 8. Print, enter value. I will input another value 8 times. 8 times I will input because loop value range is 8. Input value and it will total in the total. Next counter will increment. After completing loop, it will produce average and then it will print the result. Got that? The same thing. Now, how simplify? You can do it. In structured English, you can write in a way. It's more easier and little complicated. And same thing can be done in flowchart. Here you can see flowchart. You have initialized total with a 0 and counter equal to 1 because it is a loop. Output, enter the number of value to average. So you input number, parallelogram, output, again. These input within the loop. So input value, it will total and until loop runs. Okay, it is increment countering, counter plus 1 is increment, and number counter greater than number, counter greater than number. If yes, it will add, otherwise it will repeat till the number of time loop has to run. Got that? Yes, Umar, you got it?
Yes, sir.
This is flowchart. Basically, they have shown us you can solve your problem. You are using structured English, what to say, flowchart and algorithm or pseudocode. So these are three methods you can use to solve your problem. Got that?
Yes.
So is this clear? So here you can see the pseudocode. Okay. So enough for today.
Yes, sir.
So see you next class. We'll do some programming
Okay.
further.
Okay, sir.
Allah Hafiz.
Allah